Is my Lab 3 Circuits for Physics 2212 by Montelos Benadryl. So introduction, pretty much what we did in the lab was we built circuits, and it was to understand values like current and voltage in a circuit that contains capacitors and resistors. We didn't have to use any sort of coding for this one, which was nice. And generally what we used to measure different values was the multimeter. And so we used that to calculate electric fields and potential difference and, for circuits both in series and parallel. And it generally was just used for generating all the different values that we got that didn't require calculations. And so the system was everything that made up the circuit, and the surroundings was everything else. Pretty much for the results, we got a current that was 19.8 milliamps. So the physics explained, pretty much these are the three biggest physics concepts that we ended up using within this lab, and that was Ohm's law, Kirchhoff's voltage law, or the loop rule, and also the current law. And so pretty much what they do is saying that the current coming in is the same as the current coming out. Then the other law was that the sum of voltages across it, or like the potential difference, I guess. Yeah, sum of voltages within the loop is equal to 0. And then Ohm's law is just the three different variables of resistance, currents, and its relation to voltage and potential difference. So yeah. Assumptions of the model. So the circuit had a 47 ohm resistor, a 100 ohm resistor, 2 ammeters, and 2 batteries, each which were supposed to be 1.5 volts, but when we measured it, it wasn't that, so it is a little different. And so the diagram to the left pretty much shows the setup that we were using. And so the total resistance was 147 ohms. The current was 0.0204 amps. And then the current there, current 1 and current 2, we got to be 19.8 milliamps when measured. And so the voltmeter along the 100 ohm resistor was 2 volts, and then the voltmeter along the 47 ohm resistor was 0.8. And so that got us to get 2.8 volts as our potential difference. So this was the setup. We pretty much just did what was shown in the last bit. Rigged it up so that it would have the resistors and capacitors in line with the battery and all that. Possible errors where the multimeters used could have had inaccurate readings because their batteries could have been low and stuff like that. Human error regarding the circuit setup, we could have messed something up there. And then non-zero resistance present in areas such as the wires itself, because technically there is going to be some sort of resistance within them, even though we're assuming them not to have it. Data and results. So this graph pretty much just shows all of that. The current was measured to be 0.0198 amps throughout the path of the circuit, and the voltmeter readings would change because of the higher resistance. The resistance in the 75 ohm resistor was 45.832 ohms, and then 71 ohms within the 100 ohm resistor. And the potential differences, like we mentioned before, were 2.8 volts. Now the next bit was for the different light bulbs in that. So the RC circuit, the bulb was attached to a capacitor, illuminating it before turning off and draining the capacitor. However, too much energy could burn out the light bulb, and it illuminated less as time went on just because it kept running out of that. And so values for charging, we have different values shown for 20 ohms and 10 ohms for both charging and discharging. And we saw that the time increased by 4-fold whenever the resistance was doubled from 10 to 20. And generally the times for charging and discharging were found to be similar. So what if you charge the capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain, and then, discuss the predicted times. And so what we found is that it would be way quicker as there's no resistance, so the current would charge the capacitor super quickly, just because lack of resistance obviously means that it has to go through less. And this wouldn't happen in real life because there's actual resistance in the wires in real life. And so that's what generates the difference between the predicted time and the actual time as well.